Lions Rock Productions.
This is Jay
This
Moore.
is Greg Proops.
This is Jordan Harbinger.
This is Dexter from The Offspring.
This is Nathan
This is
East.
Sebastian Younger.
This is Rick Marotta.
This is Stuart Copeland.
This is Mick Gillette.
This is Andy Summers.
Hey, this is Skunk Baxter.
This is Gabby Reese.
This is Rob Bell.
Hey, this is John Leon Guerrero.
Hey, and this is Pete A. Turner.
Hi, this is Brian Curtice, and you're watching the Break It Down Show.
And now, the Break It Down Show with John Leon Guerrero and Pete A. Turner.
You did it. You knew what to do. I love it. First off, I love talking dinosaurs and all kinds of things. I love science. I love when science and other sciences merge. We were talking off mic about archaeological stuff, paleoarchaeology. You could throw in history and you could throw in anthropology and all these different areas combined to have multi-field or disparate disagreement and everything. But the thing I really want to start off with, and this has nothing to do with dinosaurs, but I'm curious what your thoughts are. Because of scientific naming conventions, especially in your world, it must drive you crazy when people use things like, when they say things like metaverse, and you're like, you know what? You're not really using the word meta correctly, and they start to move the word around. Like for a while, and this is just Pete commenting here on this, they were calling bathrooms unisex, like not the right word, right? But people just throw some kind of prefix or some part of a word in there, and when you guys name something, it's very specific. It can be a long name because it's a sentence in the name. Does it drive you crazy when people just make up words?
It doesn't, me personally, no, because language evolves. As a student of evolution, everything's evolving over time. And the fact that you can see it extraordinarily well in paleontology, the impact of the newer generations. So old school paleo, look at Tyrannosaurus. I mean, if you think about it, it's just tyrant lizard. It doesn't describe, like Stegosaurus means plated or roofed lizard because of the big plates that were on it. Triceratops, three-horned face. So sometimes they did it and it was tied to a specific feature on the body. But in modern days, you have animals like Suuwasia. It's a sauropod that my friend Dr. Jerry Harris named, but it was more of a tribute, taking words of the local tribes as the Native Americans, as opposed to using Greek or Latin descriptors. And you're seeing that more and more as younger folks, as people from different cultures get involved. You see the naming convention shift away from the traditional Greek and Latin descriptors into a more inclusive, if you will, a naming convention. However, I can't tell you what Onsu or Suuwasia, I don't have a frame of reference when I hear it, versus if I hear something like, let's say, Ankylosaurus, which means ankylosed or fused lizard because of the vertebrae. So it doesn't drive me mad. I love, in fact, in all of my Instagram or social media posts, I do my best to try to track down what the name originally means.
Right.
Because it's very telling of the researcher. Like the animal I've been studying a lot recently is Supersaurus. It's not a particularly great name from a scientific standpoint, and yet it is super long. So it's fitting in a way, and it does evolve. But what does trip me up is when let's say Eohippus, dawn horse. What a great name for an early horse. But we're not allowed to use dawn horse anymore as the earliest horse. It's been synonymized with a far less attractive horse name in comparison that's much more scientific. So as we work through, the rules of science require us at times to lose a wonderful name in favor of something that meets the scientific requirements of being an official name, but it was named first. And we always look at the law of priority in paleo. The first person to name that specimen and that type of animal, that name holds priority for all time.
Even if that name is silly?
Pardon?
Even if that name is silly, like the guy that finds like a certain lobster, can he just call it, that's Larry the Lobster, and it's going to always be Larry the Lobster from now on?
So from a scientific standpoint, there are criteria. It has to go through a peer-reviewed process. There's a number of steps that must be followed. And if you named it Larry the Lobster, it wouldn't pass peer review because there's the International Code of Zoological Nomenclature, the ICZN.
Yeah.
And heaven help you if they wade into your animal and it causes all kinds of heartburn. But they're also the folks who discover that, let's say I named an animal, Saurophaganax was originally called Saurophagus, lizard eater. And when it was named, that's a great name. However, someone realized that name had already been used with that exact spelling on a bird that ate lizards. So we had to rename it from Saurophagus to Saurophaganax, or even more pedantic, Ultrasaurus, which is no longer a valid taxon. But when it was named, it was actually called we had to rename it Ultrasauros because someone used Ultrasaurus ahead of time. And that level, what astounds me is how pre-internet, the paleontologists were able to know all of these disciplines and often find those duplications. Today, it's much easier.
Yeah. I'm curious. I mean, we know Tyrannosaurus Rex, we know Triceratops, Stegosaurus, and all that. And then all of a sudden, it's like we start to run out of things to say about dinosaurs. Let me take it aside here real quick. One of the things we learned from Thomas Demere, who works at the Nat in San Diego, was that he's like, oftentimes the person who talks to me, comes to my museum and talks to me about dinosaurs, will know more about the topic they're talking about than I will, because there's just so many areas. And you get some 8-year-old kid that's been completely immersed in it, and you're like, oh, actually, and you're like, wow. So your field is one of the few highly academic fields that people are, especially young boys, are just so into that they can have an enormous amount of at least book knowledge, if not like, PhD level knowledge. What are your thoughts on that? And then I'll come back to the other question.
So I love it. It's a great point. And I see not just young boys, I see a 50-50 or maybe even 60-40 mix. Women are more and more following the paleontological realm at younger and younger ages because it's cool and it's fun. And so society doesn't look askance at them if they choose to chase, go get dirty. Yes, paleontology is one of it's a Renaissance science, first of all. You need help. There's no one way any person can handle any particular animal. You need engineers, biomechanics, paleontologists, a whole field of troops. Quite often you'll see 6, 7, 8 scientists on a paper because it's a multidisciplinary approach. And with access to YouTube and the internet in general and amazing high quality photos, there are astounding knowledge levels on very young individuals because they have the freedom and the tools plus access to resources, as well as all of these giant initiatives to scan all of these historical documents. Yeah. So the Philadelphia Academy of Sciences journals from the 1800s, all of the Smithsonian pubs, they're available online in PDF form. So they can go back to the exact primary literature that I'm looking at, as well as bounce around and chase whatever fancies they have. And then they can reach out to the researchers themselves and engage. We actually offer a product called paleoportals.com. Every 2 weeks, I bring on paleontologists and our members get to hang out and ask questions directly to them. So you are spot on. I engage with children and with adults who have deep knowledge and know more about certain specimens than I do. And I'll give you a quick example. Here's a Spinosaurus we just released, and this is a 3D scan of multiple Spinosaurus bones. But there are individuals who are not AKA credentialed that would tell me, well, this is from this specimen, and that's scanned from this different specimen, and then upscaled. Their knowledge is astounding. And what's cool is they may not go into paleo, but they will use that. I have a PhD in educational technology where I studied alternative learning paradigms like homeschooling and the use of all of these tools. And one of the areas that is powerful is if a young person develops a deep knowledge in anything, they'll be able to, thanks to neuroscience, we know now, hang on additional items and learn much quicker different topics. So it's a gateway. I don't want to call it drug, but it's a gateway into just learning in general. And it can be a drug because there's a dopamine hit when you look at fossils that I get at least.
Yeah. And there's not too many things when you're young, boy or girl, whatever, when you open a book and you go, whoa, when you learn about dinosaurs, that's the sound that comes to my head. Like, the kid that that loves it. I mean, I was fascinated by it, but I didn't have that love. And to latch on early like that to something, I mean, that really can change not only your own specific life, but the lives around you as you draw people into your passion. I totally can see that. I'm so glad that you brought in the other disciplines, because that was where I was going to go at first, but I wanted to back up and cover those young kids. So when you, I mean, every day you can read about some dinosaur discovery. It's incredible the pace with which your guys' field is moving forward. But I imagine you can employ a PhD level kinesiologist. When you get to a site and you find something that's a fossil of something that's not a dinosaur, you might be like, holy cow, look, this is a whatever plant or whatever thing. I mean, there must be all kinds of things. There was a fossilized brain found the other day. That must be a specific person or group of persons you have to call to identify and write about that finding, because I don't know that we found a brain that was, maybe it's common knowledge to you, but me, I've never heard of that happening where it's fossilized in there. And then who do you have to bring in to write about that part of the find?
So, and I'll have to look up the latest brain, but we call them endocasts. So quite often the brain will deteriorate and the silt or sediment, the mud that's going in through the skull, will make a perfect cast of that brain. So you can then see all of the cranial nerves. And what's great about paleontology is you need to know a lot about a lot, or you bring in a specialist. So in that case, if I was working on an animal that had a skull, I would call in one of my buddies or find someone in the world that is a specialist on brains, because I know very little about them except wear a helmet. And that's about it. You keep them safe. But I would call in before that, though. I would actually call in, and they're unsung, the 3D technologists. So much of paleontology today has moved over to digital because it's non-invasive, non-destructive. And so I would ask them to do a scan, go down to a hospital, and hospitals love to help us out because they get to put it on their MRI machines, and then they'll scan it for us and do the slices. And now I'm articulating this brain in 3 dimensions, watching nerves potentially go through. Then we've got the artist, because the other side of paleo, back to the children for a moment, one of the reasons that kids love dinosaurs, well, 2 of them, is 1, they're extinct, but they're fearsome. So they're safe to talk about. And 2, they have really long, like Pachycephalosaurus is 18 letters long. A child learns it like that, but a parent may not be able to pronounce it. So, and the parent's knowledge is typically out of date. So it's a field where parents love them as a kid. And now fast forward 25 years, they're sitting there learning about stuff that's all new and words they can't say and all new ideas. And the child is empowered and they become that agent of knowledge and change. So it's really neat to watch little kids with their parents at museums. I get to see that all the time. And specialists, animators, 3D artists, engineers, because if I study vertebrae and you look over my shoulder here, those vertebrae, they all have a certain way they got to go together. And there's loads that you know the qualities of bone, and they can do this models. And then you go in and I've got to learn about the rocks that it was found in. So in this particular, the animal behind me, we brought in geologists who studied the flow of rivers, because this was found on the side of a river. So what direction was the water flowing? And that becomes important because now we can look at the quarry map and start making sense of what initially looks to be this disarticulated bone salad actually becomes something that science can help weave together a hypothesis. But it takes an entire village of individuals to make all of this happen today.
I love it. Yeah, it's fascinating. I put a link up here, and I'll put it up again. It's in it's on the YouTube side. But there was recently an embryo preparing to come out of the shell that was like captured in time, and within, I don't know, a couple of days of that story, Dr. Zawas, like the #1 Egyptologist you've ever heard of, they did a similar scan of a mummy. He's like, we don't unwrap mummies anymore. We scan them, right? And so this technology not only advances your science, their science, that science, this science. It's like someone goes, oh, crap, I didn't know that. Because again, we have this internet thing. We're like, well, let's just go get the dude. And so now you have this person that runs an MRI or MRE or MRA machine. There's all kinds of different styles. And they can become legitimate scientists and help you see something that, like the nerve structure of a dinosaur brain. And then that opens up all the new questions. I imagine you're like, now I really don't know anything.
Yep. Especially with brains, because the brain is traditionally perceived within evolution as very conservative because it works. It doesn't change very often. You don't move a cranial nerve's location, lightly in the grand scheme of things.
Yeah.
So, but over time, things happen, quirks, mess ups on the transcription of some DNA, and it works, and you get lucky. And so you can track those, and cranial nerves are very important to paleontologists that study skulls because knowing which bones they're coming in and out of, where they're at in relation to one another, you can see these grand, broad brushstrokes of evolution just by looking at the skulls themselves. I joke because I study sauropods, skulls are so rare. Lightning blew up all of the skulls of the animals I study. So I look at the vertebrae because there's one skull, but I have 25 presacral and up to 80 tailbones that might get fossilized. So I chose to go where the numbers were.
Are you being serious that lightning blew up that's what killed them?
I don't think it did, but if you think about lightning in today, and if you are 25 feet off the ground and lightning's around, you better hope you're not the tallest thing around. So It's being facetious, but at the same time, these things are so gigantic. I mean, you can see the size behind me.
Yeah.
If you're walking on a plain in the middle in Arizona, we have beautiful monsoons with huge lightning storms, and I just envision problems. I should actually look and see how many giraffes get struck by lightning. That would be the modern analog. And now I go reach out to someone who is a giraffe expert, and now we could conceivably write a paper, the frequency of giraffe death by lightning strikes.
Yeah. And that person, off the top of their head, they'll be like 432 a year. That's what the number, and they know it. They know it exactly. I've been waiting for someone to ask me that question for 25 years,
So true.
So one of the things we talked with Tom about is, he's like the top dog at the NAT, and there's only so many jobs where there's a natural history museum. And he's like, yeah, it's great. I'm never leaving this job. It's like a dream job. However, I don't get to go in the field. You get to go into the field. You get to teach a lot. I mean, there's all these different, it's like as you progress up the chain in your field, you often don't get to do the thing that got you in the field in the first place. And you end up running, what paleontologist is like, ooh, get my hands on this budget for the year. I got to forecast me some numbers,
So it's so funny you say that. Literally 130 minutes ago, I was corresponding with a buddy whose boss just left, and he got promoted into a new role. No title, no extra pay, but is now doing budget for 2022. And he would much rather be preparing really awesome late Cretaceous dinosaurs, but someone's got to do it. And when it takes a village, so some academics find that they take to the bureaucratic side. There is a lot of overlap in writing a paper. You have to follow a certain rubric, and all of bureaucracies have a flow. But you're right. Most paleo folks don't want to turn to that side. And when they don't, the challenge is you don't necessarily get the funding that you would get if you had someone who is paleo motivated running the shop. The money's going to go towards what their primary interest is. It's just human nature. So I do wonder if we could get a few more paleo-centric folk in some of those positions. But the overall, like the Arizona Museum of Natural History, we have a team of outsiders. We go out and excavate, but we have good weather year round. We're kind of flipped. When everybody else is out in the field, we're either somewhere else or we're in the air conditioning because it's hot here. But right now, most of the world is huddled up preparing fossils they collected all summer. We're actually out looking for fossils because the weather's perfect.
Yeah. And then the other thing that struck me when I was talking to David Norman was on the show before, I'll put a link up here in a few minutes, was there was this dinosaur, and I can't remember the name of it, and it had a complicated name, but that dinosaur was dug out of the ground by the guy who basically invented the word paleontology. Like, he goes back to the very beginning of it, and they put it in a box and they put it in an archive, and it waited for someone to have the professional time and position to be able to go, I want to describe this dinosaur. And David had to wait a long time, but he got to finally do it. And so and we have modeling and all these things that make your guys' job easier, right? But you only do get to do so much work. and only get to dig out so many dinosaurs, and it might just be one dinosaur, and you don't even get to describe it, you know? So talk a little bit about the amount of work, and then how many paleontologists can there be in the world that are employed full time in doing this? There's a finite amount of work that can be done.
So the answer is, if paleontology was a revenue generating field, it could support a staggering number of paleontologists. But paleontologists have mortgages to pay, and there's only so many museums and so many jobs in general. So paleontologists, you mentioned the San Diego gentleman who's got the dream job. I joke that jobs only come available when someone dies or retires.
That's right.
Then 2,000 people around the world will apply for one job, because of those sweet jobs just do not come very often. But when you're talking about what's available for paleontologists to work on, there is a staggering amount. So there's lots of different kinds of paleontologists. So there's your field paleontologist. They know how to find rocks in the ground. And after a couple of days, your eye would pick it up. If we went out in the field together, you know what to look for. But there's some people that have the magic and the knack, and they find things just unbelievable, and they pull them out of the ground, but they're not always ones that collect it. Just because you found it, a well-oiled machine has the finders, and think of it as a sales machine. There's people out generating the leads. Okay, I got a hot one. They move on to the next one, and they hand it off to the farmer, who goes and excavates the skeleton. And there's certain ways of doing it to maximize the amount of information retained. They then take it back to the lab, but they may not be the ones to prepare it. The preparators are the ones you see on the shows with the pneumatic drills, the tiny air scribes, grinding away grain by grain. That takes a different level of skill and training than it does the other two roles. And then once they get out of the matrix, a scientist, someone who knows the osteology, will look at it and go, oh, I've seen that somewhere. And so now it's handed off to a more traditional academic. And then from there, they bolt on the 3D scanners, the modelers, the artists, the people that make the exhibits, the educational experts at museums. What's the museum's mission? What kind of message do we want to convey, and how do we convey it? And that's a completely different skill set than finding fossils in the field. So there could be as many paleontologists as you could want to fund, because there's so much fossiliferous rock in the world. Fossils are rare, yet there are staggering amounts being pulled out every year in new places. I read a paper from some dinosaurs in Pakistan. No one had really looked there before, and they're pulling them out of the ground, and that's pretty cool. So they're pretty much everywhere we look if the right age rocks are exposed. But financially, the big problem paleo runs into is, though it provides this wonderful festival of the mind for the youth and this great way of talking about evolution through time, but outside of some commercial specimens that have received outsized attention, they don't generate a lot of revenue in and of themselves, which is why paleontologists, as much as many people would love to become a paleontologist, there's just not the jobs to do it, to pay for it.
Yeah, no, I can see it. It's an exciting field. Do you feel, is it a calling?
Oh, I joke, I like dinosaurs since I was in the fetus. So it is, for many of us who are out on the fringes of society, it is a calling. It is someplace. I joke that every single trip until recently in my entire life was to a place that had fossils, either in the ground or in a collection that I could study. I couldn't imagine going somewhere that didn't have a robust fossil collection. So yeah, I would say for many of us, it's a calling, because the work itself, though it seems maybe glamorous at times, I tell people that want to be a paleontologist, just go out in the middle of nowhere and get pretty much lost for 7 days, sleeping in a tent in a pretty extreme conditions at time. Or my buddy Jacob Jett, paleontologist out of Colorado, says, take your truck, and your buddy, and go find the biggest, deepest muddy lake to go run it into, get it stuck. Now unstick it and change the tires 10 times, because you have blowouts, you have damaged vehicles. You need to know up until recently, we didn't have GPS out in the field. So right. I went out in 97, and the GPS unit we had was military issued that said, do not allow to fall into enemy hands. Push these 3 buttons to destroy. And every day they generated a different randomized measurement disparity, which is cool until you try to go back and find, well, it's within 100 feet of that point. Well, there's a canyon and a canyon. Which canyon do you think we were in?
Yeah.
But yes, it's a calling for some, and for those that make it a career. A lot of folks dabble, and then they find, okay, that was fun. But I've also discovered the joy of museum exhibition, for instance, or they'll pivot out to another discipline, but they've got that love of it to begin with, that at least they'll give it a nod when it comes across their museum. They'll go, yeah, go ahead and bring the dinosaur in.
One of the things, and this will kind of segue us into fossil crates, one of the things that's always fascinating is no matter how great a museum is, a small fraction of what they have is what's shown. I mean, obviously, if you've got Sue, you put Sue out there front and center, and you let Sue do what Sue do. But there's molars from mammoths and all kinds of things back in the archives that you guys are studying or have to get to at some point. I think what you guys are doing with fossil crates is kind of opening up those archives to people that have the time and inclination to just let me study mammoth teeth.
So with fossil crates came about the whole concept. We originally launched what we called Museum as a Service. We were going to provide, and we still do, nano, micro, and small size exhibits to museums at an affordable monthly rate.
Right.
Because we're not looking to buy a house on a hill. We know museums have tight budgets, but we have access to really cool specimens. Unfortunately, COVID came in and every museum in the world closed down. So we had to pivot. And we pivoted to the actual crates, which, since you mentioned it, I've got one here. It comes in a cool crate. It's got a lid. You open the lid and you get artwork that we customize. We go out to a number of artists. Many of them are teenagers. They're up-and-comers. We want to give everybody a shot. But to your comment specifically, so this is a never-before-cast Torvosaurus claw. So Torvosaurus was the savage lizard, one of the apex predators in the late Jurassic. People have heard of it, and here's its tooth, but they could never actually, these aren't in museums until now. We went and scanned these. Actually, we molded these from the originals, and we give a royalty back to the museum because they need to make sure they can go do more studies. And we also use them in exhibits. We work with folks such as, here's one of my favorites. This came out, and I think I saw it in 98 in Argentina on a shelf. And it's like, look, I need this for myself. And then we turned it into, this is a new dinosaur. This is a Megaraptorid. We didn't find enough. Well, my buddies didn't find enough to name it a new genus. But what Fossil Crates is doing is bringing the museum home by having these really cool specimens that are affordable. Like we laser scanned the Tufts Love skull. This is the best 3D, the most complete T-Rex skull ever discovered. And then we laser scanned every bone and then 3D printed it. So we're trying to bring things that I wanted as a 10-year-old, as a 5-year-old, as a 45-year-old. I'm trying to make items that are items that I've seen in museums that to your point, they just haven't had the inclination, the time, the funding to go and bring some of these gems that are in the back. In 2022, we've got some cool jaws of things that have never been cast before. And they're just amazing specimens. One of the other problems we run into in paleo is, how do I say this without getting the community upset? They're just another Triceratops. So there's almost 500 Triceratops skulls that have been collected that we know of, probably more. And that's great if you're studying range of variation. But for a lot of folks in the field, it's just another Triceratops. But to me, as a purveyor of lover of fossils, if it has a really neat nose horn, for instance, or a cool tooth, well, let's even though it's a Triceratops from the scientist standpoint, from the avid enthusiast standpoint, that's still really cool specimen. So let's bring it to light and let's let folks see it.
Yeah, no, that's a great point. The other thing is, and I think we learned this from Tom, maybe it was David, but the stuff you guys have that you're working on, it's also very fragile. And the next time that a paleontologist spins around and like bangs a skull into a countertop and breaks a piece, it won't be the first time and it won't be the last. That stuff happens. And so having the ability to replicate, I'm going to shut up and let you talk.
No. I'm telling us. So this is a jaw of a Dromaeosaurus, which extraordinarily rare. And this is one that we cast and offered. But we broke this multiple times. The thing is, as long as it's not a skull or something that's irreparable, most bones we work on, some crazy, cyanoacrylates, your super glues of the world. We put them together, hold them back, and we're good to go. So though a skull itself is very fragile, and it also depends on how it was preserved. Most of the animals I work with, it's a 7.5 foot long shoulder blade or a 6 foot femur. So if I lose a chunk of it this much, I mean, I don't want to, but it's not. Right. I've got a lot of bone to work with. Yeah. However, if you're studying mammal jaws, the Mesozoic mammals, the entire tooth might be the head of a pin. And that's a very different, extremely fragile in comparison. But we break things all the time. I laugh at docents because like, don't touch that. And once I said, ma'am, I took a jackhammer and I jackhammered it out of the ground. I beat on it with a single jack. I drove it I drove a stake truck over no roads for hours, jumbling this thing around. I got it back to the lab and it was still in mostly one piece, glued it all together. That kid's not going to hurt it. But then there's liability. There's other things to consider.
And I also want to bring out the point that when you have a museum, you have a defined space, and almost like a grocery store, you're going to put Pepsi on the end cap, and you might have this off-market mustard brand. Sorry, we don't have room for that. Like you have to justify the space, and because it's a presentation, right? And you can't just say, here's another Triceratops skull. Like, yeah, we've seen 100 of those. We don't want people walking by. You want people to stop and pay attention to that specific thing.
And that is so true. And that's where like our bladed beauties are one of the exhibits we offer. We have a Utahraptor claw, which is a random side note. This was called a hand claw. So when it was named originally, Utahraptor was named from our disarticulated material. So bones were strewn across a field, and they found a number of these big claws, and they thought these were hand claws. And as they started looking at it, they realized, this is years later after it was named, this is one of the original diagnostic characters of Utahraptor is big hand claw. Well, we found it, and it turns out the hand claw is very small, and these are toe claws. But all of the mounts of Utahraptor have those toe claws on as hand claws because it's, A, where do you get the hand claw? We now finally had one last year, but B, it's not as impressive, and has a cost. And you're so right on the presentation. Because museums service typically localized populaces, a Triceratops is neat for that location, which is why you see the same couple skulls over and over. T-Rex you'll see in every museum possible, and it used to be the AMNH 5027 droopy specimen. Now it's Stan that you see everywhere, but it's because that everyone wants to see a T-Rex. But what you don't get to see then is Daspletosaurus, Gorgosaurus, Albertosaurus, these cousins of T-Rex that are also very cool, but they don't, unless you can tie them into the narrative, they don't get brought out up front unless you're at the Royal Tyrrell. They do a great job at showcasing those animals.
Yeah, and just in general, if you guys are watching this, go to fossilcrates.com, especially if you got young ones, you're doing homeschool or whatever it is, and check out what they do and see how they might help your curriculum or open your mind to dinosaurs. I mean, I think it's just a great service. And since we're pitching things, if you're watching the show on YouTube, especially, click subscribe. That helps. Go to the PayPal link. Put a little bit of money in each month. I don't need anybody else. I just need you and me to work on this together. $5 a month across a lot of people goes a long way, and I can put that money back into the show. As it stands right now, this thing's broken. I got to buy a new one. They're $1,000. So we're always pitching stuff. We always got to support the folks that do go out and do this work. I know. Look, I spent a lot of time in the desert, and this will be interesting to you. So when I was a spy in the Army, and we had these hills that we were practicing driving our vehicles over, and then they practiced scooping, and then they realized, oh no, this is not a hill, this is a tell, and it's full of artifacts.
Oh, wow.
And we had scooped dirt out and put it into what are called Hesco bastions, which are a giant basket. Imagine like a 4x4 cube of wire and fiberglass cloth, and you just fill it full of dirt, and it becomes like this giant brick full of artifacts. Oh my God, it was that stuff is everywhere. Dinosaurs, pots, stones that did things, it is everywhere.
It's so funny you talk about hitting it with a scraper. So many finds have what we call the discovery point. Oh, that's where the backhoe tore off the top. I have a beautiful cervical vertebra of Supersaurus in the Brigham Young University Museum of Paleontology collection that the top loader scraped the surface and just cut the top half off completely. It is, in a way, it's a thing of beauty because now you can see the insides that you couldn't otherwise. I'm a lemonade glass half full kind of guy. Yeah. So I'm like, yeah, we lost half of it, but look what I did get. Yeah. But not most, but many of, especially the larger bones, if you know what to look for, like, oh yeah, that's the chisel that they hit. And then there's a different sound when your chisel hits bone versus rock. There's a feel and a sound. You immediately know, oh yeah, that's cool. I might have something. And then you just hope you didn't crush something important when you found it.
We had a guy named Joshua Martin on the show the other day. This is one of the incredible things about doing this show is I get to talk to all these incredible people. He's a second generation surfboard shaper. His dad shaped 100,000 surfboards. No one's ever going to do that again. Like, it's just not possible anymore. He still does hand shaping. And he said, like, after a while, your hand just knows. Like, you're not directing it, and you feel it, and he knows which way to. And he's doing a similar thing. He's taking this blank, and he's turning it into the right surfboard for what he's doing. You must identify with that and like how you do your dance with what you find in the ground.
Absolutely. So if I've got examples where I was, cruising along, found something looked like bone, uncovered it, recognized that it was a caudal vertebra, a tailbone. And because I study tailbones, I knew which way was head versus which way was tail. And traditionally with sauropods, you find the back half of the tail. And so I knew if I went up a few feet, because it was a sauropod, I could probably find something else. And sure enough, there was the ilium. So now I'm guessing, where do I think the ilium ends? Headward. And then, okay, and I have a dorsal vertebra. And then I move forward and have 3 more dorsal vertebrae. And then there's just nothing. And historically, because of the way all the musculature goes, you get that back pelvic section. So, but that's because I knew based on just a little piece of bone that I was looking at a Diplodocus, and there's artistry. So we took it out, we brought it back, and then I actually prepared that one. It took me almost 2 years. I prepped it out in the lab, and so helpful when you have a know likely what's coming. And then it just makes preparing so much easier. So I can imagine hand shaping and feeling the wood up. This is going to not, what's important is knowing what it won't do. The master preparators will be down there with their dental pick on their magnifying glass, and they're working. And you're like, well, why don't you take that one out? And this is just say, no, don't do that. And a guy like me I want to see. And like, if you do that, bad things will happen. And I've learned, trust the preparators. They know, because that's what they do all day. It's to them. That's their calling.
Yeah. No, I love hearing about that. And I'm curious too. So when you see that tip of the bone and you can really go forward in time and go up over here is where we're going to be in 2 years digging this out. And then, if we're lucky, if I go 5 feet further, that's where the skull could be. I mean, do you project that? Okay. That's what I want to hear about.
Yep. So, and I can't tell you how many times that I've sat there in the field and we just know the skull's right around the corner because we're tracking it, and the cervicals are articulated and they're nice shape. And then we take out big chunks. The skull's got to be there, and it's almost never there. It's so heartbreaking. But we're in a way, we're like fishermen. We just keep throwing it out and reeling it in and hoping something's going to be there. That hope dies last in the paleo field. So with those examples of trying to find skulls, however, there was a group in the 90s, Western Paleontological Laboratories, Karen Cloward, Cliff Miles, Ron Muse, the whole crew, Clark, Brian. These folks went back to dinosaur localities that were the Bone Cabin Quarry. It's a very famous quarry. Literally tons of articulated dinosaurs were pulled out of that quarry and taken back to the East Coast and put on display. So they got rights because it's private land now. They went back and they excavated on it. And what they discovered was the old timers missed lots of skulls, lots of skin impression, because they were in a bone war, Martian coat. B, they were just getting the big stuff out, and C, they lacked the tools and the advantage of 100 years of learning. Right. So that team went in, and I was a graduate student in the mid-90s, and I would go to their lab all the time. The things that those folks did revolutionized modern-day field paleontology from how you collect it, how you can salvage tissue paper thin skull bones. They rewrote the books, but they were a commercial outfit. So they don't necessarily get the love that I think they should historically, because they were selling specimens to keep their excavation going. But the best specimens they would publish on, they would make sure that a museum purchased their really significant ones. But back to the Triceratops, if they found another partial Allosaurus and it was pretty beat up, but it would look great in someone's home, they weren't above selling those type specimens. And that gets into a really thorny political issue that I try to stay out of, is should we or shouldn't we? But it's definitely interesting to see how commercial paleontologists help advance the field as much, if not more, than many academic paleontologists, because if they can figure out a better way to collect something faster, they'll bring in the new tech. So you'll find that there's guys using drones now to find fossils. There's an incredible paper that came out 2 years ago. They fly a drone at night, and every second it flashes a bright flash to capture the ground. And when that flashes off, the darkness, it shoots an infrared. It's looking for a luminescence of sorts off the bones, especially the teeth. And then while it's flying around at night, they go back, they crunch the numbers, and they say, okay, go here, here, and here. And then they hand in the paper. And in the day team goes out and retrieves what they found. And it's incredible to see just the advancements technology is bringing in the last 700 days.
Yeah, that's the last 700 days. That says it right there, right? Like, this is happening right now. And, all of the studies of old things, LiDAR, access to things via drones, all kinds of things. Are we making any progress in terms of, and this will sound silly to a lot of people, but it's a real thing. The Earth changes a lot. Underwater paleontology. Like, are you guys able to really kind of have any chance of doing that at all? Because that's got to unearth all kinds of incredible things.
It does. And I was invited, and this is a dig I did not go on and sometimes kick myself for. It was a low tide dig. So not truly underwater where you need scuba gear, but the tide had to go out, so they could only work a certain number of hours every day to excavate this material. Now, this happened to be on a gorgeous beach in a very touristy area. So there was they had wonderful times when the tide came in. They went and hung out with the locals. And then when the tide was out, so twice a day they got to work. And as technology improves, as the underwater archaeology, I can completely see. I'll actually take underwater paleontology and mix it in with World War II. So one of the ships that the Germans sunk had a mummified hadrosaurus on it. So this is one of the three mummies, the gorgeous mummies, and it went to the bottom of the ocean. And we know roughly where it's at. So it would be fun to talk to one of the salvage type archaeo folks or historians that want to take a sub down and then see if we can't find, because the rock should be perfectly fine. The salt water, though it's erosive over time, it's only been 70 years. I imagine and it was jacketed. So I think it's in great shape. So it'd be neat to see if we can't pull this. The problem is it's probably 2 tons, but if we could pull it up off the ground, we'd have another specimen.
Yeah. Well, that's just an engineering problem ultimately. Right. And this is funny because the other day I was looking at deep sea exploration basically, and there was a dude who I think does almost that exact thing. And I'm going to try to get him on the show. And then if I do, you're going to be sitting there and co-host it with me, because that's what we need, right? We need these kind of things to happen to have advancements. I love the fact that underwater archaeology and paleontology, that these things are finding a home, because it's how we learn and how we evolve. What does paleontology as a science give us on a day-to-day basis? How does it contribute to today's society? So
in a lot of subtle ways, and some in your face. The in your face is the whole concept of evolution, and thus extinction really is paleontology's its wheelhouse. So watching animals evolve, and then extinction is forever. And if in the mass extinction that we're in today right now, it's going to take 1 million years or so for nature to try to rebound And we've seen it do it again and again. Obviously, the Cretaceous, Tertiary, the impact wiped out the dinosaurs, though birds are dinosaurs, so they're still with us. We argue the semantics. But paleo brings not only that concept of evolution, but also, to me, it brings about to the youth that you can find something new, that you can contribute. It's an empowering feeling. I receive almost daily individuals saying, I think I found this dinosaur bone. People are looking and they're finding, and it's making them be aware of their surroundings. So it contributes to society in terms of it provides entertainment. I mean, Jurassic Park, Michael Crichton's book was great. The movies have done a phenomenal job at the box office and really bringing dinosaurs to life. But in general, I would say it brings about all of these concepts of climate change that we're talking about and the extinction of animals. Paleo has something to say in that realm. And then just in terms of being an aspirational, motivational area for children, most people go through many go through a dinosaur phase. And it allows them to hone their linguistic skills, because they all know Paki means thick. They break it down. It learns through time as well, because time is something that we live such short lives in the grand scheme of things, that this is one of the few sciences that studies deep time, astronomy being another. And I like to find stars that are named with similar time to when the fossil was. So I can say that star's light that's hitting us today was actually emitted 70 million years ago when this animal was walking, and they're now meeting. I think that's kind of a cool way to do it.
Yeah, that's super neat to look at time in that fashion, and also let you know just how insignificant a 100-year life is. Like you haven't seen or don't know anything, and yeah, it's time. Boy, I'm always fascinated by the event that preserves the dinosaur. Like in my mind, it's like, oh, here comes this flash flood, and then they get swept away and whatever, or there's an earthquake or whatever. But I don't know. And then how much of geology is in what you have to do is you look and say, this is an alluvial field or whatever it is. Can you talk a little bit about what's the ideal situations when you can capture, a lake full of creatures all taking a drink and then boom, are preserved in some way?
So the best is an anoxic event, so without oxygen. And if you look at the Lagerstätten, that's a great German word, not for beer, though beer is probably part of it, but Lagerstätten in the sense of it's preserved incredibly well. And you see that in Canada, the Yuhu Formation, with all of the hallucinogenia and the Welwitchias, those cool kind of animals that we would have no idea existed if they hadn't been apparently hanging out on a part of a sea cliff that slumped and then slid down into a place where there was no oxygen. So there was no bacteria to digest all the parts of the animals. And then the rain of sediment buried it and pristinely preserved them. The same happens in the Green River Formation in Wyoming. You have these unbelievably, incredibly well-preserved horse, fish. You've got all manner of turtles and crocs. And what happens is they died and they end up going into this bottom of this water, calm water, that had no oxygen in it. And when there's no oxygen in it, they just fall to the bottom and they stay together. And then they're buried by the normal fact that there's always a soft rain coming down onto this bottom. The other area, like the mummies we referenced earlier, mummification is a weird thing. We don't mechanically know exactly how it happens, but we do know that it died. And while it was still fresh, so great timing, some kind of flash flood had that leading edge of mud that buried this particular animal. And whatever chemicals were in the mud reacted with the decomposing flesh to almost like create this amazing saran wrap layer around it that allows us to have such great detail. Most of the dinosaurs I study, they went the traditional way of fossils. They died. They went to where their water used to be and it was a drought. There's no water. They fall over and die. They get scavenged by other things that also fall over and die. And the insects come in and they tear it apart and it lays out for months, and the dry sun beating down. And then the flash flood comes and pulverizes, blows the skeletons up into all different directions. That's the life that I tend to work on right now, is these take lots of different puzzles, mix them together, take a bunch of parts away and say, go. And but what happens is, even there, bone, if you ever break open a bone and look, it's hollow inside. And those osteocytes, the little cells, the water percolates through, and water can have mineral in it. And it leaves all the little drops of mineral, they get stuck in those cells. And in the Morrison Formation, they're mostly radioactive because for whatever reason, there's a lot of radioactivity in the groundwater. And off topic, but an embarrassing, fun story to share. As a graduate student, so I'm always working, and I've got I'm holding the tail bones, and they're big. They take 2 hands, and I've got it on my lap, and I'm measuring it, and I'm studying it. And they thought it'd be funny to do the Geiger counter bit. So they're watching, and then what I didn't see was they adjusted the sensitivity. So they put it over me, pegged the needles, all kinds of warning sounds. And they're like, oh my gosh, what are you doing? You got to get rid of that. I've had it in my lap for hours. And they show me all the ones I touched, pegged the needle. And I truly thought I would never have kids, may die of cancer right then. It was horrific. After they saw that I was really not setting well, they showed me the sensitivity setting and said I'm okay. But paleo humor, we get.
You guys are hilarious.
To me, it was the funniest thing once I saw it was okay.
Yeah. Hey, you fell down. Are you okay? Yeah, good. That was hilarious. What's this is I don't know if anybody's ever asked you this, but every profession has its moment where you're just like, yes. What is that moment for a paleontologist, and what was that moment for you most recently?
So there's 2, and they're tied together. Funny enough, they're bookended. So rewind the clock. I'm a graduate student sitting on top of a forklift in a museum at 2 a.m, just tired, but you don't have all the time in the world. So when you're a graduate student, you burn the candle as much as you can. And I'm looking above at, funny enough, one of these backbones over on my back here, this one here, the one in the middle.
Yeah.
I'm looking at it. And it had always been called the Brachiosaurus. And it was called Ultrasaurus. And because of my sleep deprivedness, I think Slayer was playing in the background. I'm looking down on it on top of this forklift from a unique perspective. It hit me. That looks just like a ridiculously oversized Diplodocus. So I literally jumped off the top of the forklift, ran over, grabbed a Diplodocus, and sure enough, if it wasn't almost the same thing, but 4 times the size. And so that eureka moment helped solve that Supersaurus. It helped start to put this whole animal together. And then we found the quarry map. So we assembled this map of the quarry, and this happened, and we got a publication out of it in November of last year at SVP, the Society of Vertebrate Paleontologists. I published on this study of Supersaurus, and all of these bones go to one individual thanks to the fact that we now have the maps of the quarry. And by mapping the individual bones together, they're in this pocket. So that people would say, well, that's multiple dinosaurs represented because the bones are across the size of a football field. Turns out every bone that's ever been suggested to belong to a big sauropod is all in the one same spot in the quarry. So when I realized it, and I had no idea as I'm filling this out, but I kept coming back to the same spot. And then you start getting nervous. There's 3 bones left. Well, where's this one gonna? It's right there. 2 bones left. And any single bone could have ruined my hypothesis. I get the last bone out, and it drops right into the same area. And that's when I realized we don't have these 3 giant dinosaurs roaming around. Parsimony and old Occam's razor, this is all part of one animal. And once you mapped it out, it turns out to be the same animal that I'd realized in 96, or actually 95, that big bone was just a really upsized version of a smaller animal. So those eureka moments are when, luck and preparation meet. And I was extraordinarily immersed in the anatomy of these animals. So it just took a slightly different perspective, that luck, and it met all of the other stuff that I'd been collecting. And it was truly the eureka, fist pump, jump. I ran like a crazy man. I run back. And then I just did a dance, and I couldn't believe it because I'd solved it. I was so happy.
Oh, I love it. I love these moments when you can find them and you learn about what someone's touchdown is. That's great. It's just it makes me smile, to know that people have these moments. And by the way, thanks for using parsimony in the show. It's always good to add a new word and test the transcription machine to see if you can pick that.
Parsimony. It's funny because parsimony is now. Paleontology was the second discipline. Insects were the first that grabbed a hold of cladistics, which is phylogenetic analysis using parsimony. So what's the most likely? That's likely what's the case. And a lot of the sciences today, we argue over these things called cladograms. They are, this dinosaur is related to this dinosaur, and they're little trees and branches based on a matrix of characters. So on one hand, we've introduced this robustness into the paleontological community because it's repeatable. I can take your matrix and run some software and get the same output. The challenge that no one talks about is when you're looking at the most parsimonious tree to display in your relations, there can be 90 most parsimonious trees or 3,000. So then, despite all that quantitative science we put together, ultimately it comes down to that qualitative decision of which of these trees am I going to publish? And then you justify why you selected that one. But we have gone a long ways from the old timers in the 1800s that just said, well, this is Megaraptor because it has an attenuated tip. And that's it. And that they got away with that, but no longer can you do that.
Yeah. I'm curious. I've been thinking about, so I recently did my ancestry thing. And so I put my DNA, spit in the tube, send it off. And then they say, hey, you're related to these people. You're related to these areas and everything. And if me and a chimpanzee are basically genetically the same, if I had a bunch of chimpanzees spit into a tube, would they start to populate on the map and be like, you're related to this chimpanzee? And if that's true, could we make the leap and say, this Allosaurus is your great, 10th cousin, 15 times removed or whatever? Could you get to a point? I mean, if I'm 60% similar DNA structure-wise to a banana, I must be closer to, I can see fingers on a whale, even though they got flippers. What are your thoughts?
So first of all, if I had access to a chimpanzee, I would not be surprised if some enterprising primatologist has not sent a chimpanzee swab into 23andMe.
I hope so.
I would hope they have. You've given me food for thought. What primates do I have access to? I'm already running through the numbers.
Right.
So I'll call that guy we referenced earlier. He's like, yeah, come on down. So when you're talking about relationships wise, the tree is a branching tree is a great example. So at the trunk, we have whatever genetics are required to make cells work. That's where that 60% of plants come in. It's cell walls, it's mitochondria, it's all of the internal parts of a cell that without which you wouldn't have life. So once they start to split, you've got these things that the old Linnaean system called phyla. So, kingdom Animalia. Then you had phyla chordata. That means it had a backbone. So as it splits off and all the animals have a backbone, yes, you could trace it all the way back down to Pikaia from the Precambrian explosion out in Canada. That seems to be the earliest vertebrate, at least from my recollection. And if you look at humans, you've got the Australopithecines, you've got all of the older Homo genus, then they roll on down into a chimp/gorilla. So as you roll it backwards from not like the great chain of being that the Renaissance people had drawn up, but instead, if you start at the humans as a tip and you keep drawing where they keep running into them, you couldn't get to dinosaurs like Allosaurus, but you could go all the way back down to things like maybe Dimetrodon, those what I used to call mammal-like reptiles. But dinosaurs split off separate from mammals, so we can never show that we're tied to the dinosaur because we had a branch. At one point, life split. And dinosaurs went one way and mammals went the other.
Same thing with Denisovans. Like if you had like 1% Denisovan DNA, could that be another part of the branch of the tree that would get you over?
You would have to get to dinosaurs, you'd have to leap into birds.
Okay.
And so because that's how, and then we could back in through bird DNA, you could back all the way down through the Maniraptorans, so the dromaeosaurs, the velociraptors, if you will, the raptor dinosaurs that birds spun off of. But even them, they go back. But if you look at how the current hypothesis is of their relations, it takes a long time to run into an ancestor with Allosaurus that back in like the Coelurosaur, way early in the late Triassic time frame. But yes, you can play that game, and it's fun to do.
It is fun to do. And it's fun to take some of the bounds off of what's possible so you can see what's left, I don't want to put you in the grave or nothing yet. You got a long life ahead of you, a lot of work ahead of you and everything else. What is interesting to you that you just don't have the ability to do anymore? You're like, man, I would love to go down this road, but you're already on your road. You're already looking at, Supersaurus and those kind of things. What's out there that excites you that you can't do?
Yeah, that's a great question. And fortunately, when I come up with these ideas so far, I've been able to find someone to partner up with or spin it off to. But I think that from a historical, from my standpoint, I love mixing in the history of the paleontologist. And there's one thing that it's always bothered me, and it involves the namer of Brachiosaurus, Elmer Riggs. He was a paleontologist whose first paper about it said world's largest dinosaur. So there was a little bit of showman in that, and I appreciate that. But the thing is, I know he worked in Argentina, and Argentina had titanosaurs, which ultimately became Argentinosaurus. We have these giant limb materials that had been excavated. What I've always wanted to do is track Elmer. It would take a while. Go look at what Elmer's South American expeditions were and see if he just ignored these giant bones or if they weren't there yet. Just because I've always been curious, when you announce world's largest in something, that's a bold proclamation in Nature. That's where he published it. It wasn't just like it was Science or Nature. It was not a fly-by-night journal. Right. But another area that, and I shouldn't say that, there's many wonderful journals, but the big emperor journals. Yeah. But another thing that I would love to do involves going back and looking through all of the localities of the Morrison Formation, and John Foster is working on this, but trying to get nice constraints and maps to rebuild Western North America 145 million years ago, because there's so much evolutionary information that's there to be gleaned that I just don't have there's no way I can go back. It's a completely different freeway, and I can't get on that freeway now. I can just read about it when it's done. But I would love to see that tying together of the different quarries. And again, John Foster out of the State House Museum in Vernal, Utah, he's written a book on it, and he's done a lot of work, but it would take 5 or 6 more Johns just to try to get it to the level that we would love to see it at.
I love it. This has been such a fun conversation. Everybody should go check out Brian's work over at Fossil Crates, fossilcrates.com. It's exactly how you'd want to spell it. Nothing complicated there. Anything in closing at all? Anything at all, Brian?
I actually, a couple super quick. One, you mentioned a spy. And I would love to chat at another time and learn more about it. But I can tell you that paleontologists have run across the problem of being accused of being spies because we're out in the middle of nowhere, often deserts. We're looking for rocks. Yep. We run into this problem in southern Arizona with the Border Patrol. They don't believe that we aren't narco traffickers or human traffickers, that we're really looking for rocks on the ground. So today you run into this problem of what a spy would run into, and it's a great disguise in a way, I suppose, because once they trust, he's just crazy. Well, now I can look at all kinds of things. That's why I got into photography. I kept getting dropped into places with beautiful wildlife. Yeah. I'm like, the heck with the bones. I want to look at this black mamba that almost killed me.
Yeah. Yeah. It's so true. And the funny opposite of that is because I take that approach, like when people see me, they're just going to assume that I'm a spy. I just start there. I'm like, I'm here to find things out. I'm going to ask questions. I'm open with it. If I say I'm a spy, people don't believe me. So it's the opposite. It's like, no, I'm telling you, is that true?
That is awesome.
Yeah.
Well, thank you so much for having me on. Yeah, I've got hundreds of stories. I have this thing for years and years, I've been collecting stories at the Society of Vertebrate Paleontology annual meetings, because once they get 3 beers in them on the beer night, the real stories start flowing. The challenge is I can't share them because it's a small community and we'll know who they're about. But someday I can share these things either when I don't have to worry about it or when they're passed away. But I love the old timers and hearing the travails, because 2 of the disciplines that I could drop you in today, if I put you into a school room in 1872, you'd immediately know you're in a school room. If I put you in a dinosaur dig in 1872 or 2042, it's a dinosaur dig. There's some areas that the more things change, the sameness still sits there because it works.
Yeah. Well, let's come back on and let's do some more. Let's get Tom, you and I together and have some beers and tell some stories.
I've got some other folks I can recommend as well who are wonderful orators, who are extraordinary storytellers that I love hanging out with. So definitely a pleasure making your acquaintance and hanging out with you this time. It's been wonderful.
Okay, stand by.